Hello everyone, and welcome to the most cryptic game dev podcast in the world, the House of Games. Today I'm joined by two very unique NFTs, aka nasty, fucked up, trash people. My host, Ono, and a returning NFT who knows a thing or two about you and your CPU, Mr. Odo. Now, let's mine down that door and see what this week has to offer in the House of Games.
Welcome everyone to this episode of House of Games. And to correct my co-host, our guest is actually not me twice, it's Oswald from episode 25 about Catpunk. So listen to that if you want a full introduction. This week we are going to talk about backwards compatibility and sort of the history of backwards compatibility, spoken through the different console generations. So, Oswald, you are our expert panel for this episode. So, do you want to take it away and just start off on the topic of backwards compatibility?
Yes, thank you. To do this right, I have written some stuff down. I even got a complete Excel sheet of all the generations with their CPU architecture. So, please forgive me if I sound a little bit robotic. To understand compatibility, let me explain the very basics of architecture of the central processing unit, or the CPU of a computer or console. At its core, and this is really pun intended, CPU architecture is about what the instructions of ones and zeros, or bits, mean for the CPU. You might know every bit in an instruction corresponds to a pin on the CPU receiving or emitting a high or low signal. If the CPU has a different architecture, an instruction might look the same in bits, but mean something totally different. I really wanted to get that right, so I wrote it down. Although you're a programmer, Rune, you also program, you both know a little bit how a CPU works, right?
When you said pins, is that like when I built my computer, I put a CPU in? Is that the pins you're talking about? Those things that goes...
The pins of the socket, yes.
Ah.
I thought you were gonna guess for bowling pins or something.
Bowling pins would be fun, but they are a bit big for a CPU socket. Can you imagine? Because a CPU has at least 64 pins. If it's a 64-bit CPU, they have more. Sometimes maybe 128.
Interesting. I got them sort of confused with the pins and the silicon thingies that are like in millions and billions of those, you know, the ones in there.
Oh, the transistors.
So I thought they were the same thing, because now when you said the pins, and then I thought about when I built my computer, like, but those aren't that many. Surely that's not pins. But, so that's pins, and then, but you said 64. It could be, yeah.
They are in a square. They don't look that many, but if you've got only 64 pins on your CPU, you've got 8 by 8. And I think a normal CPU has like, 16 by 16, so that's at least 256 pins. So those bits of the instruction correspond to a pin on the CPU. Not exactly, this is oversimplified. But those instructions in the CPU, they are all written in 64 bits of a number, so to speak. So that's 1010, etc. That's one instruction. And as I said, if the CPU has a different architecture, an instruction might look the same, but do something totally different. So say on one CPU, 1010 might mean, okay, add these two numbers. And on another CPU, it might mean, okay, eject the CD now, please. This is not really possible, but if you would run one program from the first CPU on the second CPU and it does a lot of addition, then suddenly your CD tray might pop out and pop back in for no reason at all.
Why doesn't it mean the same thing on two different computers? Is that the software that makes them do different things?
Yes and no. The thing is, different CPU has different meaning for ones and zeros. You can optimize a CPU by, say, have it less instructions. If it has less instructions, it needs less transistors, so it will draw less power. If you then want the CPU to do more, to be more expandable, you'll give it more transistors, which means these transistors, they will be, again, controlled by pins, and these pins are then controlled by those bits you put in as an instruction. It might sound complicated, but if you've ever made an electronic circuit, it's kind of how it looks.
I imagine it a little bit like different languages. So say that if you say something in Swedish, it means something, and if you say it in China, it means something completely different because they have different tones and stuff. So when you say hey, that means hello in Swedish, and maybe it means your mother is a murderer or something in Chinese. I don't know.
That's a perfect analogy.
Yeah, Kant in Swedish means edge, but in English it's a really bad word.
We're not swearing, we're just talking edge cases.
I have so many of those examples, like shin shin, cheers, you know? And that means penis in Japanese.
Yeah, that's the thing that happens. Yeah, that's exactly why one CPU might not run a program that works on another CPU. But then it gets complicated because there's lineages between CPUs. One CPU can be based on a certain CPU. For example, the PowerPC CPU is based on a RISC CPU. But if another CPU is also based on RISC, then some commands that are made on the PowerPC, or we'll talk about which CPUs these are because this is very cool. If they are both based on the same architecture but have additions that mean something different, then you'll have the same problem. If you want to understand the backwards compatibility problems and the amazing story around this, you need to be familiar with a couple of architectures. First off is RISC, which is the most basic kind of CPU you can have. RISC, R-I-S-C, stands for Reduced Instruction Set Computer. In its core, it's basically a full processor, but they took some instructions out. So you have a very limited set of instructions, so you can make simple computing things. A RISC processor will be present in things like DVD players or microwaves or those LCD games you had in the 90s. x86, on the other hand, is your standard PC processor, like the IBM compatible. We're doing this podcast online, and I know we're all on PCs here, so I'm pretty sure what you're working on right now has an x86 processor. Next one I want to talk about is the ARM, ARM. This is the processor in your smartphone, which is a bit slower, not very expandable as the x86, but is very power efficient.
I had a question about those. What stops us from having these very quiet and energy efficient ones? Just make them bigger and pop them in a PlayStation 6. Why wouldn't we do that?
Because they don't have a lot of instructions. The x86 has more instructions, so they can do more things in less time. For example, this is not how it really works in CPUs, but if you multiply 3 by 3, you get 9, right? You can do this multiplication at once, or you could add 3 again, and you get to 9. But that's an extra step. So ARM does have a multiplication function, because it would be stupid if they didn't have one.
The number of instructions, is that limited by hardware or by software? Why don't we just do the hardware that you have for phones that are quiet and energy efficient and pop them in a future PlayStation 6? You said that it had more instructions, the ones that you usually use for consoles. So what does more instructions mean? Does it have different hardware or different software or some kind of combination?
If I would say firmware for a CPU...
So is that software?
Yeah, that would be software, but the thing is, because what we call software is baked into the CPU. So every CPU has their own program, so to speak. And this program, this corresponds with the architecture. It's a program made in transistors.
Right, so it's hardware then.
Yeah, but how it reacts is software.
Okay, I guess.
So that's a really good question. Is this hardware or software? Both and neither.
It is limited by hardware because you can't just ship a different software with it and then it has a different architecture.
There is no way to update the software in a CPU.
No, exactly. So hardware then.
Yeah.
And that also determined the size of it. Thus, we don't have them in consoles because consoles need more information thingies you mentioned. So that makes them bigger.
The ARM is present in most portable consoles. So it is available in consoles and it can do a lot just as a big processor or a PC. You might have noticed your phone doesn't have 220 power supply.
So what is a 220 power supply?
You know the power supply in your PC?
No.
Yeah, Rune, I know you're in Japan, so that's 100 volts, but...
So the 3 pins thing, I suppose.
Yeah, the 3 pins, yeah.
I usually recognize it as the same one for the computer and my coffee pot.
Yeah, your computer draws power like a coffee pot, and your phone draws like at max 5 watts.
But actually, nowadays, my computer that I'm using right now is using a USB-C.
Yeah, but USB-C is...
The future's now, old man!
Yeah, we can skip to the end and say Apple is trying to use ARM processors for their current PCs, but that's a whole different ballgame. It's all very fascinating, and I think it does deserve to be talked about. I don't know, for brevity, where I should stop. This is such a big rabbit hole, and we're just skimming the surface here. To finish the story of different architectures, I want to introduce one last architecture, because this is the most confusing one. Up until now, we had RISC, a very simple processor, x86, our PC processor, and ARM being our mobile processor. Last one I want to introduce is the PowerPC, which is not for PCs. It was the processor in the Mac computers up until 2005. And you might think, okay, what's this weird processor? Why are you talking about this? It will be our main character in our backwards compatibility story.
Oh.
What a cliffhanger.
The x86 is the PC processor. It was mostly made by AMD and Intel. The PowerPC is not for PCs. The PowerPC is a Mac processor. And it's made by IBM. So this is a small example of how confusing CPU architecture can be. And we have only got 4 processors here.
Wow.
There are many more. And that's why I will not be talking about Sega in this podcast, even though I really want to. Because Sega used a real big slew of all different kinds of CPUs in their consoles, and we're not going to talk about it because then we will be here next morning.
In practical terms then, so what does that mean for backwards compatibility?
I'm glad you asked, Otto. I'd like to start with the 6th generation of consoles, which is the PlayStation 2, the Xbox, and the GameCube. As you might know, the PlayStation 2 was very compatible with PlayStation 1 games. And that was a very good call because it is one of the most sold consoles of all time. I think it's in the top 3 at least.
It is.
They could do this by having the exact same processor in the PlayStation 2 as in the PlayStation 1. The MIPS R5900, which is a RISC architecture, which means they made a specific set for the PlayStation, which was then slightly expanded, but I think not even, for the PlayStation 2.
Expanded in this context, are we talking about hardware or software?
Again, hard and software. It's the program on the CPU.
Yeah, alright, so they expanded the number of transistors, I guess.
I don't think they really added much to it, because they are both called the MIPS R5900, which is a RISC architecture with an emotion engine expansion. And the real big difference between both CPUs is their clock speed, because the PlayStation 1 had about 34 megahertz, and the PlayStation 2 had almost, but not quite, 300 megahertz, which is almost 10 times faster.
Yeah, so then they would have to change the hardware to get to that.
What you do to make a CPU faster is change the clock. There's this clock that gives pulses to the CPU, and on every pulse an instruction is done. Not quite, but kind of how it works.
But when you say change the clock, it's not like I go to my living room and change the time on my clock. What is a clock?
It's not that kind of clock, it's more like a pulse crystal, so to speak.
I'm thinking like frame rate. You increase the frame rate and then stuff happens faster.
Yes, exactly. It's like the frame rate. So they changed the frame rate of the CPU to something 10 times faster.
Yeah, so say that it takes like 200 frames to load this game and then it takes 20 frames instead to load it. Something like that, I'm imagining.
Yeah, that's kind of how it works, yes. And that's how they got more polygons, more colors, and all that kind of stuff into the PlayStation 2.
But is that a software setting or a hardware setting? Is that the same as overclocking, like you could do now? You go into your graphic card settings and then just up it, and then all of a sudden it's faster? Or is it... Imagine this. You would take a PlayStation 1 and then you rip out the CPU, and then could you transform that into the same thing as is used in the PlayStation 2 without changing the hardware?
You know, you might. But I'm not sure, because for that you'll need to dive really deep into the hardware, which is hard if you don't have the documentation. And the documentation is classified by Sony.
Yeah, of course. Hypothetically,
it could be, because it's the CPU, as far as I can see, has the same instruction set, same base, same everything, basically. But yeah, we are now only focusing on the CPU. There are also things like the graphics card, the sound card, and all those things. I hope they are on the same place in the architecture of both things, because you don't have only a CPU, you also have the motherboard. I wouldn't know, but it might be possible to change the CPU. But you won't, because it's soldered on. There's no easy socket to get it out of. This will be funny further on in the discussion, by the way. Spoilers. This was just the PlayStation 2 in this generation. And the nice thing about the RISC processor is that it's easy to optimize, because you hold all the instructions. And that's why we had a very big PlayStation at the beginning. And at the end of the generation, we had a very small PlayStation. You know, the PlayStation 2 Slim? I really love that console. The Xbox, on the other hand, you might have noticed there is no Slim Xbox. That's because the Xbox in this generation had an Intel Pentium 3 processor. An x86, which is a normal PC processor. I've got one right here under my desk. Microsoft wanted to get in on the consoles. They were in PCs. They had an operating system for PCs. So why not make a PC in a console form factor? And that became the Xbox. And that would have been perfect for backwards compatibility. But it won't, and we'll get to that later. Because I want to introduce the Nintendo GameCube here.
Proceed.
The Nintendo GameCube uses the IBM PowerPC 750 CXE Gecko, which is a PowerPC processor, which is... Don't leave me hanging here, I told you.
It's something that Mac used and then they stopped using and then went back to something else.
Yes! Perfect! The PowerPC. So the GameCube uses a Mac processor.
Oh.
Which is also why it has this really nice small form factor.
Oh.
But what makes it a Mac processor? Is it just because Mac uses it, or is it manufactured by them in some way?
No, I'm calling it the Mac processor because Apple was the main user of those from the 80s up until the mid-2000s. The PowerPC is RISC-based, which means it's very optimizable. It's not very expandable.
I'm raising my hands to the audio listeners like a little student. It made me think, you said it's a Mac processor or thingy in the GameCube. Why would they go that route? Do you think it has something to do with the fact that this is their first disc-based console? Because prior to the GameCube, they only had cassettes. And what kind of processor did they use back then? What was the benefit to use this particular processor?
The PowerPC uses much less power. You might have noticed the Xbox is a big, beefy thing, and that is because it needs a lot of cooling. And it needs a lot of cooling because it draws a lot of power, because the CPU has a lot of transistors, because it has a lot of different instructions.
Okay.
That's kind of how this all falls down. There's a good reason not to use an x86 processor, because it...
Which one was that again?
That's the standard PC.
Oh, okay.
It's a bit hard to call the x86 a PC processor, because there's also the PowerPC, which is not a PC processor. Very confusing, so I'll keep repeating everything. I don't expect anyone to get this all at the first go.
No, listen.
Yes, please, everyone, listen to this 5 times.
Yes, please.
This is kind of how the 6th generation is laid out. It's a very nice compilation of all the processors that were popular at the time. You had the PowerPC, the x86, the RISC, and then the next generation came, which was what I call the unfortunate generation.
Mm-hmm.
So the Wii looked at the PlayStation 2 and was like, I want some of that backwards compatibility. It uses not the exact same processor as the GameCube, but it is kind of the same, where the GameCube uses the PowerPC 750CXE Gecko. The Wii uses the IBM PowerPC Broadway, which is about 2 times as fast as the GameCube, and that made it perfectly backwards compatible with the GameCube. Very good idea. Except the CPU is not the only thing that determines backwards compatibility, because the rest of the console looked nothing like the GameCube. The Wii looks nothing like the GameCube. So they had to make this one side of the Wii all GameCube compatible, with all the memory cards, all the connectors for the controllers, which nobody had because GameCube wasn't sold very well. The Wii sold a lot of times, and it was backwards compatible, but I don't think anyone really played GameCube games on there. Did you guys have a Wii, by the way?
Yes, but I've never played a GameCube game on it. I can't even remember. Was there like sockets for GameCube controllers? And a card reader?
Yeah, there are 2 flaps on the top side of the Wii.
Huh, suppose I never opened those.
There are flaps on the Wii and you have never opened them.
Doesn't ring a bell at all.
Virgin flaps then, I guess.
Oh, boo! Yeah. So that's kind of how the Wii went. The second unfortunate candidate in our generation is the PlayStation 3. I would have loved to be a fly on the wall when they designed the PlayStation 3, because they really wanted backwards compatibility. They used the same controllers, they made a memory card reader, but they made the wrong memory card reader because you can't read PlayStation 2 memory cards in a PlayStation 3. And they used a RISC-based processor. Unfortunately, the lineage goes RISC, PowerPC, and then Cell. Cell is the PlayStation 3 CPU.
Question here. You said the PlayStation 3 used a RISC processor and it's a Cell processor. What is the difference, or what's the categories here?
Okay, so in levels, at its core, you have RISC.
First of all, levels. What does that mean?
Inheritance.
What does inheritance mean?
Like a family tree?
So is it oldest and then newer?
No, it's like a family tree. So you have the RISC instruction set. There's a base RISC instruction set, which has very basic instructions, like add, subtract, write to memory, etc. Then came the PowerPC, this Mac processor.
And that's a child of the first one.
So to speak, yes.
And it's a child because
it has the same base instructions from the RISC. So technically, you can run a RISC program on a PowerPC CPU.
Alright, yeah. With you so far?
Yeah.
And then the Cell processor, where does that fit into this tree?
So the Cell processor uses the PowerPC as a base.
Right, so that's the child of the PowerPC and the grandchild of the RISC guy.
Man, it sounds like a proper family.
Yeah, RISC is the grandfather, PowerPC is the father, so to speak, and then the child is the Cell processor.
Alright, super, got it, I'm with you.
Yes. But something went wrong here, because in the PlayStation 2, Sony used an expansion on RISC called the Emotion Engine.
So that's a bastard child then?
Or a mother.
It's an uncle.
An uncle, alright.
So it's a kind of brother of the PowerPC then, the Emotion Engine.
Ah, I got it.
Yes, and this is where the analogy falls apart, because the child of Cell, the programs that run on Cell, I'm getting confused myself. So the instruction set of Cell is not compatible with the Emotion Engine, because the Emotion Engine, the PowerPC, most likely have a couple of commands which have ones and zeros, which are the same, but mean something totally different.
So it's the evil twin of the PowerPC then?
You could call it evil, but having this kind of adversary in hardware is silly, so to speak. But yeah, sure, it's the evil.
We all know they did it on purpose, those evil fuckers.
It's not necessarily a twin, it's more a younger brother. The Emotion Engine is a younger brother of the PowerPC, so the evil younger brother.
Okay, I get it.
So they got the wrong child. Mostly because Xbox tried to beat them to this generation. Xbox was a new player, and they were very fast with their next console.
Which was?
The Xbox 360. So Sony was scrambling to get everything ready and tried to make this new console, the PlayStation 3, and it had to be backwards compatible. I think at the last moment they found out the cell processor is not compatible with the Emotion Engine processor. What are we gonna do?
How did they find that out at the last second?
You know that console generations are currently shorter than game development times? There you have your answer.
So they were already developing games for it, and then...
Yeah. They found out too late. And in the very first PlayStation 3s, they had this chip, especially for PlayStation 2 compatibility. And that chip was actually a complete RISC processor, which they eventually used in the PlayStation 2 Slimlines.
But the PS3, the first models were backwards compatible. But they solved it just by basically cramming in another PS2 in it.
Yes.
Yeah, I think I remember when I did buy my PS3, I didn't know that there was a difference, so I bought one model, and then apparently there was only like 1 or 2 models that were backwards compatible, so I just missed out on that whole thing.
Yeah, it was only the first PlayStation 3s, they were massively expensive. I had one, there was only one model that was completely backwards compatible, and that was the 60 GB version.
I have one too. And I have the PT demo on it too, which is, the... makes it even more valuable.
That thing must be worth a fortune.
Which one is that?
It's a playable trailer. It's Hideo Kojima and some famous director who made this horror game. It was sort of shadow dropped at some PlayStation event.
Oh, Guillermo del Toro, maybe.
CCC. And then I downloaded it, and then they took it off from the stores. So anyone who has that game can basically sell that PS3 for, I don't know if it's worth much more now, but that's it.
I still have my 60 GB PlayStation 3, but it died. It had a yellow light of death.
Oh.
Yeah, and even worse, it was from watching too much Netflix.
Well, I got the same thing on my first PS3, actually. When I played Uncharted 3, I think it was. For some reason, it just broke down, and I tried to fix it and apply new thermal paste and shit. I never got it working again. And then I saw, like, the week after, release notes for a patch to Uncharted 3, which said something like, oh, now we fixed the thing that broke PS3s.
Ooh.
So if I would just not have played that week or something, then maybe I would have another one. But oh well.
Yeah, that's a kind of problem you have with new processors. The cell was not very matured, so that's why it got hot, and that's why it broke itself.
I also remember from the conversations before the PS3 was launched that the cell processor was supposed to handle more like AI stuff in the games. But it was kind of interesting that in the end that didn't matter. Gamers just want a better graphic, it seems like. But it's a novel thought.
That's possible. So, I saved the best for last, which is the Xbox 360. So, PlayStation 3 was scrambling because they had a very hard competitor being Microsoft. Microsoft really wanted to get a good console out. So they needed cheap hardware. Now, as you might have noticed, the 7th generation with the Xbox 360 happened about around 2005. Do you remember what happened in 2005? Because I already told you.
Mac stopped using something.
Yes, Mac stopped using the PowerPC processor.
Fuck, I'm such a good student. God damn it.
Woo! Straight A's.
Yeah, because this is very important. This means that the market suddenly had a lot of very cheap PowerPC processors because Mac didn't need them anymore. So what did Microsoft do? They saw these cheap processors and put them in the Xbox 360. I am not kidding. The Xbox 360 from Microsoft uses a Mac processor. And you can tell by the outside design, because if you put an Xbox 360 next to a Mac, you can see, wait, they've got kind of the same dimensions and design philosophy. So why backwards compatibility to the Xbox wasn't really there?
But then, hypothetically, you could play Mac games on the Xbox 360, I guess. Or the other way around.
Yes! I think, yeah, it should be possible to play old Mac games on your new Xbox. Maybe not quite, because there's also the amount of bits in the processor, which can put a wrench in the whole idea.
So bits, what was that again? Oh, right, the pins. Right, got it.
Yeah, the pins. You have 64-bit processors and 32-bit processor. Old Mac processors probably have like 32 or 16.
It's interesting you bring up all of these backwards compatible things, because on a lot of podcasts they talk about it and no one seems to know why. And I have never heard these stories from Phil Spencer or the PlayStation people why their consoles are not backwards compatible. Because thinking about it, it sort of sounds like something Xbox wouldn't want to say back then, like, well, we're using a Mac processor because they're rivals. Thus, the Xbox 360 is not backwards compatible. But yeah, you hear all these podcasters sort of speculating in why things aren't backwards compatible. But it sounds like you have a pretty good understanding in why that is.
I studied computer sciences, and one of the subjects we had was computer architecture. Computer architecture is not the full picture, but it can give you an understanding of why something is backwards compatible or not. It's a good thing we're not talking about emulation here, because that would make this podcast also like 3 times as big. Because you have the computer architecture, but there's also the operating system that runs the computer. It's very hard to emulate Xbox on a PC, even though they have the same processor.
So, and that's due to the operating system rather than the hardware.
And that's due to the operating system, if you want to keep the story very, very short. So, where were we? The Xbox 360 is not backwards compatible with the Xbox because it has a completely different architecture. If you might have remembered, back in the day they were very wishy-washy. As you said, Phil Spencer doesn't want to say that for many reasons. I think 2 of them. One is nobody wants to hear about computer architecture. I mean, I'm very grateful I can tell this story to you guys because it's been with me for so long and I really want to tell anyone. But who wants to hear this?
I do.
We do, but Phil Spencer doesn't tell this to their investors because it's not something those investors are interested in. And second, the only thing he can say is, yeah, sorry, we broke backwards compatibility, sucks to be you. Backwards compatibility is very hard, mostly because when you stick to one architecture, it doesn't really guarantee that you can grow your performance with your console. If you go back one generation, the PlayStation 2 was bashed for having low performance. The GameCube had much better performance. Didn't really help the sales of the GameCube. It was the backwards compatibility that helped the PlayStation 2. But you can't stay on low performance forever.
I'm just speaking as a layman here. So the thing is with computer architecture is that to run a program, you compile the program and then that translates like a hello world statement into ones and zeros for the CPU to understand. To emulate a game from the Xbox or wherever, those are already compiled, so therefore you can't run them on another architecture. But then I imagine something like this. Couldn't you have like, I don't know how it works in real life, but imagine you have at the top here you have the application and it's compiled and it's sending down instructions towards the CPU, but then you just slide a sort of translation software or something in between that just sets this zero this way and whatever, so it works on whatever architecture you're running, and then we just make it compatible even though a bit slower. Or is that how emulation works, perhaps? I don't know.
That is the exact explanation of emulation.
Oh, I'm a genius!
Yes, emulation works by reinterpreting every command for a certain program. The problem is, to reinterpret those commands, you need extra clock cycles. So instead of having one clock cycle per instruction, you now have one instruction saying, okay, is this a 1? Yes or no? Okay, yes. Next instruction, is this a 1 also? No, this is 0, okay. And then like say 10 or 100 instructions later, you think, oh, so this wants me to add 2 numbers. And that's why emulation is slower.
Very interesting.
Yeah. It's why it's my favorite subject to rant about. Maybe it's time to move on to the next generation. We have the Wii, the PlayStation 3 and the Xbox. And then we get to what I call the boring generation. But before we get to that, in 2014, AMD came with a line of processors for the AM1 socket. Up until this point, AMD was known to be very power inefficient, not quite as fast as Intel, and they had only 1 or 2 sockets. They had AM2 and AM3. And suddenly they made the AM1 socket, which counted backwards from 3 to 1. The AM1 didn't exist before then, and they only had 4 processors to get for that socket. My favorite processor in that lineup was the AMD AM1 5350 processor, which had 4 cores and was 2 gigahertz and was available for only $60, which was a massive deal at the time. I mean, a massive deal being it was very cheap to get, fantastic to build computers with. I built 3 computers with that processor. Nobody else noticed, only me. Well, maybe some people, but there were a couple of things they did with this processor, because it was not just a processor. It was also a GPU, and it had a network chip, and also a sound card. So if you compare a motherboard from an AM1 processor with an AM2 or any Intel processor of the time, the motherboard is very empty. There are no chips on there because they are all in the CPU. The GPU on the AM1 processor socket was actually pretty decent. It was low to mid tier. Also, this processor was very efficient in power. And I was like, I like this processor. As I said, I made 3 computers with this. And then I saw the architecture of the PlayStation 5 and the Xbox Series X. And now I want you to guess what kind of architecture both those computers have.
You're asking the wrong person, buddy.
It sounds like they had that one.
Yeah. Yeah. Okay. In our story, we had PowerPC, we had x86, we had RISC, and we had ARM.
ARM.
Yeah, I'm guessing that too.
ARM is more for mobile things.
Power PC because... No, wait. The PC one. Because they're more like PCs.
Yeah, the PC one. Which is not the PowerPC. Yeah, you're right. It's the PC one. It's the x86. I saw the specifications for the PlayStation 4 and the Xbox One, and I was like, hey, I know that processor. I made 3 computers with that. And even worse, the PlayStation 4 and the Xbox One have the exact same processor. You have the AMD Zen 2 processor, which is a 64-bit x86 processor. And then I was like, okay, this is very good for backwards compatibility, because it's a PC processor. We have been gaming on PCs for ages by this point, which also means that the Xbox One should be backwards compatible with the original Xbox, but not with the Xbox 360. They didn't implement backwards compatibility with the original Xbox, which I find a very big shame.
So what would implementing backwards compatibility mean?
For the PlayStation 4 and Xbox One, you mean?
Yeah, so you said the Xbox One wasn't compatible with the original Xbox, even though it should have been possible.
Yeah, it's a different operating system. Also different bits. So you have the original Xbox and the Xbox One. This is getting confusing. So the original Xbox was 32 bits and the Xbox One was 64 bits. While Windows can switch between 32 and 64-bit programs no problem, it does mean you have to do a little tweaking in the operating system.
So would that be something that you would do for the whole operating system, or something that you would have to fix per game?
It should be a thing you should fix in the operating system, but it doesn't guarantee it works in every game.
So it would be probably something you would have to fix in every game, I guess.
It's a thing you have to fix for every game in the operating system. You might have noticed on Windows, not every PC game from 1995 is playable on Windows 10.
I can imagine that as a game company, you wouldn't want to go in and fix a game that's 20 years old from a console that's dead, and then Microsoft wouldn't want to do that either for the game companies for free.
Yes, so that's why we don't have backwards compatibility from the Xbox One to the original Xbox. Theoretically, you should be able to run Xbox One games on a PlayStation 4.
But, yeah, that's the operating system again then, I suppose.
That's again the operating system.
But then, hypothetically, say that you were to jailbreak one of them, then you would be able to create a very efficient emulator that would play one on the other.
Yeah, what you're talking about is probably a wrapper?
Like Wine or Proton on Linux.
Yes, exactly.
Ooh, I got it right.
You know, the acronym WINE means wine is not an emulator.
Yeah.
That's because it's a wrapper. It kind of sort of takes the program, puts it in the CPU, but if it does calls to the operating system, it says, oh no, you don't have to go to this part of the operating system, you have to go to that part.
For those who don't know of our listeners, Wine and Proton are applications that you can use to play Windows applications or games on Linux. So one example is the Steam Deck uses that to enable playing Windows games for the Steam Deck without the game company having to update it for Linux.
I just got Proton on my Steam Deck because I downloaded some, mods for Final Fantasy VII Remake, like different outfits and stuff like that. I think I told you, Otto, the Linux layout on the Steam Deck is really sleek and beautiful. It sort of made me want to go over to Linux on everything.
Cool. Well, I would just warn you before you do it on desktop, it's a completely different experience. I can assure you.
On the Steam Deck, it looks beautiful.
Yeah, I can imagine. I haven't played the Steam Deck, but I can imagine since everything is just done for you. But let me tell you, having worked with Linux in my job for quite a while and done it also as a hobby, if you don't like typing stuff to make things work, then Linux is not for you.
I love the command line in Linux.
Yeah, me too, absolutely. But you gotta be into that stuff. If you just want it to work, don't go near Linux.
It does feel fantastic once you get it working, by the way.
Yeah, absolutely. But it's sort of like climbing a mountain. It could be quite horrible on the way there, but you have to sort of enjoy that journey through the snow and wind to be able to get to where you want to go.
Maybe I should get back to the story because we're actually near the end.
Yeah, sure, absolutely.
We have the PlayStation 4 and the Xbox One. They have basically the same processor. AMD was really the winner in this generation because the Wii U crashed totally with the PowerPC. Wii U had a PowerPC processor. I think it was backwards compatible with both the GameCube and the Wii, but I have never checked.
Wow.
Does anyone of you have a Wii U?
I've only owned a Game Boy as far as it comes to Nintendo, so no experience for me.
Okay, so I think it's backwards compatible and I should have found out for this podcast, but I'm sorry, I didn't. Maybe some of the listeners can tell us.
Yes, that would be great.
Yeah, PowerPC was winding down at this point and they shouldn't have gone with PowerPC in my opinion. So, a thing you need to know about computer architecture and how CPUs are made. If you have a multi-core processor, it always goes in powers of 2. So you have either 2 cores, 4 cores, or 16 cores. But what sometimes happens is when baking these processors, not every core comes out well. So you have like a quad core with 3 perfectly good cores, but one of them is damaged. You can do 2 things. You can chuck out the whole processor, or you can sell it as a triple core. And that's why you sometimes see 6 core processors, or maybe 10 core processors.
Right.
With that in mind, if you look at the Wii U, using an old processor, the Wii U has a triple core processor. So it just takes a lot of CPUs which are made, and some of them might have a defective core. They turn off that core and then they can just use the processor again. They also did this in the Xbox 360, which also had a PowerPC triple core, which might explain why there are so many red rings of death on the Xbox 360. I'm not sure if that's the real reason, but if you put a CPU in there of which you think might be defective.
I mean, they literally took broken CPUs and popped them in the machines.
Yeah.
Huh, interesting.
They probably weren't all broken, but some of them probably are, yeah.
Weird, I'd never heard that actually.
It's a thing that happens. So the Wii U failed and we got the Switch. And the Switch, for this story, I left out all handheld consoles because all handheld consoles use ARM, at least since 2000. Before the 2000s, it's a whole different story, but let's not get into it. This is why I call the last 2 generations the boring generation, because PlayStation 4 and Xbox One, they are just PCs. Then the PlayStation 5 and Xbox Series X came around. It's the same story. They are all using AMD PC processors. And AMD is the big winner here, the producer, because the ARM processor in the Switch is also made by AMD.
Very nice. So that means that compatibility and also, I would guess, compiling games, porting them to the different consoles will be a lot easier because you only have to account for differences in the operating system but not in the CPU architecture.
Yeah, they have kind of the same performance, they have kind of the same instructions, they do have a different operating system, but I think at this point the operating systems will be similar enough that the programmers don't really need to know the differences. They are just handled by the compiler, and the compiler is made by either Sony or Microsoft. That's kind of how that works. The Switch is not backwards compatible with the Wii U, as you might expect, if only because it doesn't have a CD drive.
Right. That would be kind of cumbersome, I think.
I have no idea how they would put a CD drive in there.
You just have it like the PSP. Just flip it in the back.
Yeah.
But then I guess if you shake it a little bit, it's gonna be broken.
It's a shame I'm not focusing on handhelds because the PSP had so many nice features with the PlayStation 3. Did you know you can wirelessly connect your PSP to a PlayStation 3, pop a PlayStation 1 CD in there? Doesn't matter which model. Every model can do this. Every model of a PlayStation 3 can accept a PlayStation 1 CD, play it, and then have it streamed to a PSP.
Wow.
Cool.
That's really cool.
If you still have a PlayStation 3 and a PSP, I highly recommend you try this out.
Yeah, that sounds cool.
Just a heads up, you have to use the PlayStation 3 as a wireless point because the PSP doesn't accept current wireless encryption.
Alright. You can't use WPA2 or whatever it's called.
Yeah, they only have WPA1.
In layman's terms, you can only have unsecure password on your Wi-Fi.
Yeah, the PSP can't give a password to your Wi-Fi because of complicated technical reasons. To wrap this all up, this is how all backwards compatibility went the current and the last generation. The current generation is perfectly compatible with last generation. And looking at the architecture right now, I think the next generation is going to be the same story. Because they are using PC processors. PCs are not going anywhere. PCs are getting stronger and stronger.
Do you think Xbox will have another console though? Or do you think they're trying to just get into game publishing? Xbox and everything, that kind of stuff.
They will probably use an x86 for the next generation.
Yeah, really? I think it's possible they don't bother making an actual console and just try to get Game Pass, like Xbox Live, whatever it's called. Like a Netflix service on everything.
I've never heard that, actually.
Yeah, and maybe publishing games on Switch and PlayStation, like a third party would.
A bit like Google Stadia.
Yeah, but then it would be rather more like PlayStation Plus than Stadia, because with PlayStation Plus, the rendering of the game isn't streamed necessarily, but you can still just download the game and have the actual machine you're playing on render it.
I don't know if there will be a next Xbox if you look at it from that perspective, because on hardware it can't compete. It's just the same and it's selling less.
There's just so few competitors in this space. It doesn't matter if it sells less or if it doesn't win them any money. It still makes them look like a gaming company because they are also one of the big ones. There is a Microsoft console, but if there isn't, then they would just fade into the background and, maybe they own a lot of game studios, but Microsoft wouldn't be a household name in the gaming space, I think.
The problem for Microsoft is that they were big on PC first, and then they made the Xbox, and they kind of lost focus. And then Steam came in. And Steam is actually making money from all the PC gaming, or at least the most money. And Microsoft tried to make money with the Windows Store, and that kind of backfired.
I bought one game on Microsoft Store, actually. The remake of Age of Empires 1. So, there's one for you, Bill Gates.
I can very certainly predict one thing about coming consoles, and that's there will probably not be a PlayStation 5 or Xbox Series X slimline. There will not be small form factors of the current gen consoles because they are all using PC processors.
Oh, really? What about Pro versions, bigger and beefier?
Oh, probably.
Did you say PlayStation 5 or the PlayStation 6?
The PlayStation 5 slimline will probably not be here because it's using a PC processor. I find it kind of disheartening they are using PC processors because there are a lot of instructions in there that they don't need. You might know expansion cards on your PC.
Yeah.
That translates to PCI lanes on your processor. I am fairly certain there are PCI lanes in a PlayStation 5 and an Xbox Series X saying, any day now I might accept a card. And it's not there because there's no card.
Technically, they could do it slimmer, but just make it a bigger surface area. So it would be like a carpet PS4 or something. Like a yoga mat version of the PS5.
Oh, God. The PlayStation Yoga.
Yeah, exactly. You just have it as tablecloth.
Actually, there is a video of someone who made a Super PlayStation Slim on YouTube.
Probably with water cooling, I think.
Yeah, maybe you're right. I wasn't a CPU expert by the time I watched it, so if I can watch it now, I would totally get it.
What would be fun? Theoretically, you would be able to get a PlayStation 5 or an Xbox Series X and solder out the CPU and just put a beefier PC processor in there. I have no idea if that's possible. I don't think you get very much improvement from that, but yeah. The thing is, and I hope I'm saying this right, because I think the GPU is baked into the CPU at this point. It's on the PCI lane probably to the CPU. But looking at the AM1 processors from 2014, I think they would have gone that route. If you really want improvement, you have to find a PC processor with a beefier GPU in it. That would be very hard to find. I think PlayStation and Xbox have custom versions of those.
Right.
Well, you have to come back when the next generation is out and see if your prediction is right. Then we can talk emulations.
I'd love to, but I think next generation it will be like, hi guys, it's the same, bye.
Well, we could do a follow-up now that everyone here knows how the CPU works and what's factored into backwards compatibility. We could do a follow-up episode about how to think about it as a game creator. I mean, when you're creating games now, what to think about to make your game future-proof. Say that in 10 or 15 years, would your game be playable or will it not be? And or how could you fix that? Will it be just a clusterfuck to fix it? Or how could you just think about it to make it future-proof if that's a goal for you? Something like that.
Ooh. There's no straight answer for that one, which would make it a very good episode. I can give you lots of examples right now, but we're running out of time. It's it would.
Yeah, don't save it for the next episode. We don't want to spoil anything.
We'll save it. Oh, this is gonna be a good one.
Good, very good. All right, I think that wraps it up for this episode. Is there anything else you want to mention, Oswald, before we end the episode?
Yes, I should have said this at the beginning. I am a developer, designer, and consultant on a freelance basis. I also have projects of my own, which is called My Face Your Music, which you can now wishlist on Steam.
Way!
Woo!
If you hear this, thank you for sticking around. And although, Rune, thank you for having me. It's been a blast.
Yeah. Always fun to have you here.
Always fun.
My pleasure.
Rune, do you have any other questions before we end the episode?
What's the meaning of life?
X86, I think you said.
Really?
Yes.
Yeah, right now it's x86.
Okay.
Everything is a PC processor made by AMD.
All right. Good.
All right. Well, thank you, everyone. Thank you, Oswald, for being a great guest and giving us a good lesson on how CPU architecture works. Thank you, Rune, for being a great co-host, as always. And thank you, everyone, for listening. See you next week. Bye-bye.
Bye.
Goodbye.